Hi guys, I'm going to talk to you a little bit about completing the square today. These notes will actually carry on to a little bit of what you're going to be doing the next day. Um, so when there's a leading coefficient that was not discussed in class, this is for the people who are remote and just watching the video. This is going to be a little bit more than what was covered in class today. Okay, so first a quick review on simplifying radicals. Don't forget, when you simplify radicals, you just need to find the biggest perfect square that goes into it. So like the square root of 8, you might get perfect squareless. And 4 goes into 8, so you would just change that to 4 times 2. The square root of 4 times the square root of 2 gives you 2 square root of 2. And obviously it gets more difficult than that as the numbers get larger, but that's the gist of it. And then the other thing you need to know about simplifying radicals today is when you have things that look like this, 5 plus or minus the square root of 16, that's going to come up some as we solve quadratics. That's 2 problems for the price of 1. That's 5 plus the square root of 16 as one of the problems, and 5 minus the square root of 16 as the other. So it's 5 plus 4, which is 9, and 5 minus 4, which is 1. So there would be 2 answers there, and that's how that would simplify out. We're going to talk about some perfect square trinomials and another method to solve quadratics, really. Okay, this is what's not covered in the Ingenuity, and that's why we're not going to be doing the Ingenuity lesson. There are 3 different forms a quadratic can appear in. The first one is standard form, and that's ax squared plus bx plus c. All quadratics can be written in this form. And we talked about it being good for finding a certain piece of a quadratic, and that is the y-intercept. It's good for y-intercept because it's really easy to plug in 0 for x, and the y-intercept would just be c. Other than that, it's not good for much, okay? Then we have factored form, which looks like this. I'm going to put an a here because there can be what they call a non-zero constant in front, a stretch factor, if you will, not at the end, but like this. This is called factored form. And the problem with factored form is not all quadratics can be written this way. So because not all quadratics can be factored, not all quadratics can be written this way, but it is good if it does come up. It's really good for the x-intercepts, because x-intercepts means y equals 0. And if y equals 0, that means that either this guy or this guy has to be 0 because these two are being multiplied by each other. And then the x-intercepts would be d0 or e0 because you would just change the sign. And the last form that we're going to talk about briefly, and we'll look at it more later, is this vertex form. And it looks like this. And it's obviously good for finding the vertex, and it's also good for graphing. This is how we graph. It's called ready to graph. All quadratics can be written this way. And it's also good for solving because what happens is it takes that ax squared plus bx plus c way of looking at things where there's an x squared and an x and you can't get x by itself, and we can change it. And the process of changing this to this is called completing the square. Since they can both be written that way, you could take anything in standard form and change it to vertex form, and it gives you just one x. So you can solve it by getting x by itself. And you can't do that if it's in standard form, but you can if it's in vertex form. So what we're going to do today is we're going to complete the square, which changes something that looks like standard form into something that looks like vertex form so that we can solve it easier. Now, the big thing about vertex form is this guy right here. That's called a binomial square. And there is a binomial square in every vertex form. So we're going to spend some time looking at that a little bit closer to start. Okay, so we're going to find the perfect square trinomial, write it as a binomial square, and then we're going to solve it from there. So take a look at these binomials squared. When you have a binomial and you square it, you end up with what we call as a perfect square trinomial. And we talked about that with factoring patterns, and it's kind of hard to notice. And what happens is you take this x plus 3 squared, and you know that's the same thing as x plus 3 times x plus 3, and you would double distribute, and you get this x squared plus 6x plus 9. You take the x plus 4 squared, and you get this. And there's some patterns that you will see. The first pattern is obviously the 3 is squared, the 4 is squared, the 5 is squared at the end. But how about this guy in the middle? Well, this comes from taking this guy and then doubling it. The 3 squared is 6. The 3 times 2 is 6, 4 times 2 is 8, the 5 times 2 is 10. And that's because the O and the I of FOIL are the same and it comes up twice. So what you can't maybe notice right from looking at it is the relationship between B and C, because B and C are also related, because sometimes you'll just have one of those pieces and you'll need to know the other. And what happens is that C value is what you're going to get. If you take the B value and you divide it by 2, if you divide that B value by 2, that's what gets you to that 3, and then you square it. So if you take the B value and divide it by 2, square it, you'll get C. So look, 8 divided by 2 is 4. That's where this came from. 4 squared is 16. 10 divided by 2 is 5. 5 squared is 25. 12 divided by 2 is 6, and 6 squared is 36. So this is going to be important because it's going to help us find missing pieces of trinomials, which will help us write binomials squared. So here's some more examples. I don't really need you to look at the one with the leading coefficient because that's kind of tricky. But if there's a minus sign, you're going to have a minus sign here still. This binomial square will have a minus sign. It keeps the sign of whatever is in there, and it's just doubled. So what would this give me? This will give me an x squared. The 0.5, if you double, 0.5 times 2 is just plus 1x. And then 0.5 times 0.5 is plus 0.25. So what would be missing here in this k value? And that's tricky because a lot of times kids want to say it's 13 because the square root of 169 is 13. And that is correct. The square root of 169 is 13. But remember, to get from here to there, you had to double it. So if you remember, C was B over 2 squared. C in this case is the 169. So 169 is B over 2 squared. When you square root both sides, you get 13 is B over 2. Actually, that K value was 26 or the negative 26, depending on how you're looking at it, because you have to take half of it and then square it to get the 169. But what we're really going to be worried about today is finding that third piece, because that's going to help us the most. Problems like this and this. So how could you find this third piece? Half of 10 is 5. 5 squared is 25, and it's always going to be positive at the end. How about this? How do you take half of a half? Well, you just multiply the tops, keep them on top, multiply the bottoms, keep them on bottom, and that's 1/4. That's the half of B. When you square that, you square the top and square the bottom, so this is 1/16. And how about here? How can you find that middle term? Remember, the square root of 36 is 6, but that had to be doubled. Remember, you had to take half of it first, so that would be a 12x. Half of 12 is 6. 6 squared is 36. It's going to be important, especially that you can find this last C value on these perfect square trinomials to help us when we change from standard form to vertex form. So now let's look at why we want to do this. Well, we want to do this because it's going to help us solve. Remember, when you solve and you have a number squared equals 25, there's two possibilities of what that number can be. X could be a positive 5 because 5 squared is 25, or it could be a negative 5. So don't forget, when you square root both sides, you need to say to yourself, oh, don't forget your plus or minus. It always comes with two pairs, a plus or minus. Anytime you say the word square root both sides, you need to say plus or minus. So looking at a problem like this, if you square root both sides, the square root and the square cancel out, and I'm left with x plus 3, but this is going to be a plus or minus 5. Now, to get x all by itself, I'll subtract 3, and I'm going to write it like this, negative 3 plus or minus 5, and that's what we were talking about before. There are actually two answers here, negative 3 plus 5, which will be 2, or negative 3 minus 5, which is negative 8. So you're looking for two answers, and don't forget your plus or minus before you subtract over the constant that was in the parentheses. Okay, so why don't you take a minute and do these two? You might pause it if you want to. This one is a little bit trickier. When you divide 2 by both sides, you get -4. And that might make you feel funny because this is kind of new. We just did this last week for the first time. When you square root both sides, you still have to say plus or minus. But what is the plus or minus the square root of -4? Well, remember, that means there's going to be an I involved. So the square root of 4 is 2, but these are imaginary, so you're going to get plus or minus 2i, and that's going to happen some. Same type of thing here, square root both sides, except this time it's not imaginary. You get x minus 3 is plus or minus square root of 49, which is 7. Add 3 to both sides, and you get 3 plus or minus 7, which is 2 problems, 3 plus 7, which is 10, or 3 minus 7, which is -4. So we practiced solving, and we practiced, we're not going to do this one right now, finding missing pieces. So let's see what happens and how we can put this together. Well, let's say you're told to solve this guy. Well, if you notice right away there's a perfect square trinomial here, this problem becomes a little easier. And I'm not very good at noticing it personally, but this is the same thing as x plus 6 quantity squared. If that equals 25, I can solve it just like I did that last problem. I square root both sides, I don't forget my plus or minus, and x plus 6 is plus or minus 5. Subtract 6, and I get -6 plus or minus 5, which is -6 plus 5, and -6 minus 5, which is -1 or -11. But what if you didn't notice it? Well, if you didn't notice, your other option, and probably the best option, would have been to get 0 on one side, because you can't get x by itself. So then we try to get 0 on one side. And what you actually could have done on this problem is x squared plus 12x, this will be plus 11 equals 0, is you could notice, hey, I think this factors. So you make a list of 11. 1 and 11 gives me 12. So this is x plus 1, and x plus 11 equals 0. Well, you know that's two things being multiplied by each other. So one of those two things has to equal 0. And if x plus 1 equals 0, a little glitch there, you're going to get x equals -1, and you're going to get x equals -11 by setting the next guy equal to 0. So that's another way you can solve it. But let's say you didn't know it factored or it didn't factor, because sometimes things don't. There has to be another option, and that's what we're going to talk about next. These are the ways you can solve. And it says boxes, and I'm going to tell you why. But this is called completing the square. If you're trying to solve something and you can't tell it factors, you can change it to vertex form. And we do that by getting 0 on one side. And then you figure out what perfect square it's closest to. And what I mean by that is, remember, we had this x minus h squared plus k. Every vertex form has a binomial square, so you got to find the one that's closest. And then you'll make some sort of adjustment to make it equal what you have. So let's look at that problem we just did, 2 different ways already. Maybe. What'd I do? Undo that. I made it blue. I don't want that. Okay. Why is it blue? Okay. How can we do this? So we're going to get 0 on one side. We're going to subtract 25, which is what we did before. And we get x squared plus 12x plus 11 equals 0. Now here's how you complete the square. You may remember from Algebra 1 where you could draw boxes. You can model this out with squares and rectangles. And x squared looks like this. And then little x's look like little rectangles. This is what an x looks like. Well, I need to make a perfect square. So I need to have this tell me what my picture is going to look like. And I don't want to put it lopsided on one side. I need it to be perfect. So I need it to be a square. So this always tells me what I'm closest to, the first 2 pieces. And what I'm going to be closest to is an x plus 6 square. Because what I'm going to do is I'm going to take that 12x, I'm going to put half on one side. I'm going to put half on the other. You won't always have to draw these out. It'll just take you a few times to understand what the pattern is. But these are all x's. And these are all x's. And I evenly distribute them out. So now it's a square. And the size of the square is an x minus 6 squared. Because this is an x by x. This is a 1 by x. So those are all x's. So it's an x minus 6 by an x minus 6. Well, that's an, oh, I put a minus, these should have been plus, excuse me, an x plus 6 squared. So this guy is closest to an x plus 6 squared, but that's not what it is. If it was an x plus 6 squared, all these little pieces in here would be ones. And that's 1, 1, 1, 1, 1. So there's 6 by 6 or 36 little ones in there. So what this would be, if it was right, would be an x squared plus 12x plus 36. But that's not what I have. I don't have x squared plus 12x plus 36. I actually have x squared plus 12x plus 11. So how can I get from 36 to 11? Well, I'm going to have to subtract 25. And that will equal to 0. This is called vertex form because x squared plus 12x plus 36 minus 25 equals what I started with. So this guy is called standard form, and this guy is called vertex form. And vertex form is really nice because it takes the x squared and the x, and it just changes it to an x. So now I can get x by itself by just doing some algebra. I'm going to add 25 to both sides, and I get an x plus 6 squared is 25. And now it's just like that problem we did before. Square root both sides. Don't forget your plus or minus. X plus 6 is plus or minus 5. Subtract 6. X equals negative 6 plus or minus 5, which is negative 6 plus 5 and negative 6 minus 5, which are those two answers we said. Okay, so let's look at another example. We're not going to do the one fractions yet because that's a little messy. Let's try this guy. Okay, so this is not a perfect square trinomial, so we need to get 0 on one side. So let's subtract 18. Well, now I get x squared minus 10x minus 11 equals 0. Does this factor? The answer is actually yes. So you totally could factor this, and you should. If you can see that it factors, factor it. It's x minus 11, x plus 1. If you make your list for negative 11, 1 and negative 11 gives me negative 10. So if that equals 0, then I can solve it very quickly, and x equals 11 and x equals negative 1. If you can see it factors, you should factor. If you don't, though, we need to do a method that always works, which we're going to use completing the square. So we change that to x squared minus 10x. We said minus 11 equals 0. We need to find the square that this guy is closest to. Well, that square is closest to an x minus 5 square. And we get that by taking that x squared. The minus 10x's have to be split up even. So we're going to put 5 on each side because we need a perfect square. And this time they're minuses because the minus 10x, so it's x minus 5 by x minus 5. But if that's what my picture is, what do I have in the corner? Well, I have 5 by 5, which is 25. So this is an x squared minus 10x plus 25, but I don't have 25. I have minus 11. So what I'm going to have to do is I'm going to have to take away the 25, and I'm going to have to take away 11 more. So I'm actually taking away 36 because 25 minus 36 is 11. Now, this is standard form, and this is vertex form. And the reason this is nice is because I can get x by itself really easy by just adding 36 and square rooting, which is what I'm going to do. So if I add 36, I get an x minus 5 square equals 36. Square root both sides, don't forget your plus or minus, and I get x minus 5 is plus or minus 6. Add 5, and I get 5 plus or minus 6, which is just what we saw when we factored it. 5 plus 6 is 11. 5 minus 6 is negative 1. So this method also works. Okay, I'm not going to look at this one because it factors. You can try it on your own. But I do want to look at another example that's from your worksheet. Let me get out of here. Pull up your worksheet. And we're going to take a look at question 5. So what happens if it doesn't factor and you had to do this? What would it look like? So let's get 0 on one side and add 12. For a minute, you might think this factors, because 72 has lots of factors. But when you make your list for 72, you get 1 in 72, 2 in 36, 72 divided by 3, 3 in 24, 4 in 18, 6 in 12, and 8 and 9. None of them get me to 16. So this doesn't work. So I have to complete the square. It's really my only option. So let's go ahead and complete the square here. Which square would it be closest to? Well, it's going to be closest to, you look right here, an x minus 8 square. If I had an x minus 8 and I had minus 8 on this side and minus 8 on this side, what would be in the corner? I didn't draw it all out, but you get the idea. What would be in the corner? Well, there would be 64 in the corner because 8 times 8. So that would be x squared minus 16x plus 64. It's always positive in the corner. Well, how can I get from 64 to 72? Well, I'd have to take the 64 and I'm going to have to add 8 to it to get to 72. This time I didn't have enough. So 64 plus 8 is 72, and now they're equal. This is standard, and this is vertex. So this is nice because now I can solve, but something strange happens, and this is going to happen sometimes. When you subtract 8 from both sides, you get x minus 8 squared is negative 8. When you square root both sides, you're going to square root a negative, which seems weird, but you'll get x minus 8 equals plus or minus. This is going to be negative 4 times 2 because this is an I. So you're going to pull the I out. Don't pull your eyes out. X minus 8 is 2 square root of 2i. And then to get x all by itself, you'll have to add 8 to both sides. And you'll get 8. Don't forget your plus or minus because I did forget to write it there. Plus or minus 2 square root of 2i. And the I has to be outside of the root. So sometimes you're going to get imaginary answers and you're just going to leave them that way. And that's going to be okay. Okay. Actually, I changed my mind. We'll do the leading coefficients tomorrow. You're going to skip some of these on the homework. The ones that have leading coefficients, you'll skip. So you're going to skip questions. I wrote them down in the slideshow. 18 and 8 and 9 and 6. Those are the ones you're going to skip. So that's just an introduction to completing the square, and we'll do a little bit more complicated ones tomorrow.